Hello and welcome. In this video, we will provide an overview of deep belief networks and show you how to implement one using the Tensorflow library. One problem with artificial neural networks is that backpropagation can often lead to local minima. This occurs when your error surface contains multiple grooves. During backpropagation, you may fall into a groove that is the lowest locally, but not overall. Deep belief networks, or DBNs, solve this problem by using an extra step called pre-training. Pre-training is performed before backpropagation and can lead to an error that's in the vicinity of the final solution. We can then use backpropagation to slowly reduce the error rate from there. Deep belief networks can be divided in two major parts. The first part contains multiple layers of restricted Boltzmann machines in order to pre-train our network. The second part is a feed-forward backpropagation network, which will further refine the results from the RBM stack. Let's first import the necessary Python libraries. Before we continue, let's briefly review restricted Boltzmann machines, or RBMs. RBMs are shallow neural nets that learn to reconstruct data in an unsupervised fashion. An RBM takes a set of inputs and translates them into a set of numbers. These numbers can then be translated back to reconstruct the inputs. This process allows an RBM to automatically extract meaningful features from a given input. RBMs are composed of a visible input layer and a hidden layer where the features are learned. There are no connections between nodes in the same layer. Our deep belief net will need to use RBMs, so let's declare one class for them. For our example, we are going to use the MNIST dataset, which is a commonly used benchmark dataset of handwritten digits. Now that the RBM class is created and the MNIST dataset's loaded in, we can start creating the DBN. For our example, we are going to use 3 RBMs, one with 500 hidden units, one with 200, and one with 50. We are generating a deep hierarchical representation of the training data. Now we need to train our RBMs, which, if you recall, is the pre-training step for our network. Now we can convert the learned representation of the input data into a supervised prediction, which will be a linear classifier. Specifically, we'll use the output of the DBN's last hidden layer to classify digits using a shallow neural network. Let's define this network now. Now we can execute our code. This will show the accuracy of our deep belief network for each epoch. By now, you should understand the structure of a deep belief network and how to implement one using the TensorFlow library. Thank you for watching this video. To practice and learn more, go to the lab and run the code for yourself.